So now that we have reviewed simplifying rational or radical exponents, we are officially ready to review some of the properties for these types of exponents. So these are the properties of radicals or properties of rational exponents. So for all of these properties, we want to begin by letting n be an element of the integers such that n is strictly greater than 0. And then we also want to go ahead and let a and b be real numbers. Now, the following properties are going to hold true, provided that the numbers within the radicals are real numbers. So property 1 tells us that if our index n is an even integer, then the nth root of a to the n is actually going to be equal to the absolute value of a. So to help us better understand this property, let's consider the following example. Now, suppose that we're asked to simplify the square root of 169. Now, we're asking ourselves what factors can be multiplied together 2 times to give us 169. Now, because we know that 169 is equal to 13 squared and it's equal to negative 13 squared, we know that we need to consider 2 distinct cases. Or if we wanted to put them into one happy case, we could incorporate the absolute value. So in simplifying case 1, since 13 is positive or non-negative, we know that the absolute value of 13 is just 13 itself. Versus in case 2, since negative 13 is negative or less than 0, we know that the absolute value of negative 13 is going to be the opposite of negative 13. So negative times the negative produces positive 13. So in both cases, we attain the same answer, but again, we got there 2 very different ways. Property 2. Now, if our root index is odd, like a 3rd root or 5th root, then the nth root of a to the n is simply a. And this is because we know we have no domain restrictions on odd root radicals. Property 3. So property 3 is called the product property and is exactly the same as the product property that we saw with integer exponents. So notice here that we have the product of 2 radicals with the same root but different bases. So since we know that these roots are in fact exponents, we can simplify this and think about this as one happy radical expression, or the nth root of the product a times b. Property 4. Now, property 4, again, is very reminiscent of the quotient property that we saw with integer exponents. So observe here that we have 2 different bases, but the same exponent. So in order to simplify this expression, we can combine these 2 under one radical and say that we have the nth root of the ratio a by b. Now be careful here, because we have a fraction, we want to be sure to incorporate that b cannot be equal to 0. And last but not least, property 5. Now property 5 is called the nested property for radicals. And again, this is actually reminiscent of the properties of exponents with integers. So here we have the nth root of a, or excuse me, we have the nth root of the nth root of a. So in order to make this a little bit easier to simplify, I'm going to actually rewrite these radicals in their exponent form. So we can rewrite the mth root as 1 over m on the outside, and then the nth root of a on the inside as a to the 1 over n. So when we have it written in this form, we realize that we have an exponent raised to another exponent, which is going to allow us to rewrite this as a to the 1 over n multiplied by 1 over m. So multiplying our 2 fractions, we have a to the 1 by n times m. So we can take this now and rewrite it back into its radical form as the simplified expression, the n times mth root of a. So this is a general summary of all of the properties for radicals, which we can now practice with the following examples.